What's up guys, my name is Daniel and this is another video. This is actually the second video of functions, so I'm explaining functions. However, if you're just here for a video regarding passing by reference versus passing by value, then this is also a perfect video if you already understand what functions are. But if you don't understand functions, check out my previous video. But if you understand functions and you just want to understand value versus reference, then this is the perfect video for you. Okay, so what is passing by reference and what is passing by value? So before I get into anything, right guys, I just want to explain something. I just want to explain that this function add, which I already created, right? This function just adds two numbers together. If you look at it, it takes two values. We declare some variable inside, and then that sum variable is an addition of these two numbers. And then we return that sum value, and then we can do whatever it is that we want with it. And in this example, I basically printed out the add function, which in this case, 100 plus 10 will give us 110. You can go ahead and run this program. And then after that, what we want to do now is that I want to explain something. Just because num1 is here and this is num2, and also in the actual function itself is num1 and num2, it doesn't mean anything. You can have different variable names here. So I can have my number 1, my number 2, my number 1, and I can basically have that everywhere. So my number 1, and then I can have my number 2, my number 1 and my number 2 here, right? And then I can just pass these like this into this function. Even though they are different variable names, this will still work. So it doesn't matter what the variable name is. As a matter of fact, I didn't even have to include these two variables here. I can just pass in 10 or 100 directly and it'll still work. It just wants numbers that are integers. This function just requires you to have numbers that are integers. Doesn't matter the name of the variables, doesn't matter if they're variables or not, or they're just numbers. As long as they are of the type int, then it will work. Okay, I'm going to return it to how it was. I'm going to leave it as this for now. Okay, so just wanted to make that clear. So you can go ahead and run this program and it should work. Now, so what is passing by value? So basically what's happening here is that whenever you call this function add, what ends up happening, the computer actually creates a copy of these variables. So these are variables that are already declared, right, and are basically in your memory, in the computer's memory. They are there, they exist. When you call the function add, when this function gets processed, basically what happens is that num1 and num2 are created. There are new variables in memory that are created, and basically what ends up happening is that there are new memory locations in the computer, and if you change certain things, then nothing will happen. Let me give you a demonstration. See, you have num1 here, right? If I were to change num1 and I would say num1 is equals to maybe 3000, right? And let's just say I wanted to print out my number 1, right? And I would just see out my number 1, for instance, and end line, right? And yeah, let me run this just to demonstrate. You'll realize that 110 is from this cout statement, and then the second cout statement is number 1 that I'm trying to print out. And you can see that even in the add function, even if I change num1, nothing happens. So nothing happens. It doesn't get set to 3000. It's still 10 because it's still using this my number 1, because they're separate memory locations that have been created. I'll demonstrate what I mean by memory locations. So just bear with me for now, right? I have a whiteboard. I'm going to explain everything. However, if we pass in by reference, right? If I were to pass in by reference, right, I'm going to create a separate function called pass by reference, right? I'm going to say int add by ref, right? just the name of a function, doesn't matter. I'm gonna just maybe have it have the same contents as the first function. I'm just gonna copy this, not cut it. I'm gonna copy this as well, paste it over here, and then as you can see, these two functions do exactly the same thing, right? So okay, we already saw that this doesn't work, so let me just put it back to its normal state. Now if I were to have this function add by reference, and inside of this add by reference, this function, the only difference is that in the parameters of these two, the parameters of this function, I have an ampersand over here, and I have an ampersand over here as well. This is the variable ampersand. If I were to pass these ampersands inside these variable parameter declarations here at the top, then it changes everything, because now we're passing these values by reference. When we call this function, we're passing these values in here by reference, and we're not passing it by value anymore. So let me show you a quick demonstration. Basically what happens is that now if I were to change this num1 and I were to try and call it over here, right, num1, which is this one, and now I'm still calling that function over here, right? If I run this, you'll see something different. Okay, so we're not calling add by reference yet, so let's just call that function. I'm gonna pass it here, add by reference. I'm gonna pass in these two numbers, right? And then let's see what happens to our number1. Let's see the output of my number1. So, and as you can see there, my number1 becomes 3000. It has changed. So what exactly is happening here? Oh, and why the ampersand? Why does the ampersand make a difference? So I'll explain that with a whiteboard just now. Okay, so let me just demonstrate what happens. So basically, in your computer, in everyone's computer, you have memory. Okay, so you have RAM inside your computer. I'm sure you've heard of it. So what happens is that if this is RAM, and RAM is in a linear fashion, that's why I'm drawing this very straight rectangle. RAM has memory location addresses here. So these are like slots inside of the RAM stick. So let's say this is address 1, this is address 2, this is address 3, etc. So on and so forth. So if you have a function which is called function add, right, and it takes in the num, and it also takes in the num, curly braces, and then say you have the main function over here, right, curly braces, and then you've declared the number1, right, num1 here it's 10, num2 is 100, and when you call the function add, and you call it normally by reference, right, you call it normally, let's say you didn't include the ampersands here, right, you're still calling it by value, right, you're calling it by value, which num1, num2. What happens is that when these values are declared over here, what ends up happening is that inside the RAM you have memory locations that are filled up. So 10 goes in here, and then num2 is 100 goes in here. That's basically what happens in RAM. Now when you inside of the add function, if it's not passed by reference, it's still passed by value. If you now start changing things, num, right, if you start changing things, remember, since it's passed by value, this function add creates brand new memory addresses. It goes all the way, and somewhere inside your RAM it creates memory addresses. So it creates 10, and it also creates 100, right, because it's passed by value. It just copies the data. This is copying the data. It copies the data all the way to these new RAM locations. Now, so therefore, when you start changing values and you start saying num is equals to 3000, what ends up happening is that the 3000, or the variable num, gets changed in this memory location. so this memory location becomes 3000. That's why if you were to see out in this same function, if you were to see out num, you would get your value of 3000. You would get 3000 because that's exactly what you're dealing with, right? However, when we're dealing with passing by reference, okay, this is a different thing. When passing by reference, all of this copying and pasting into the new memory location doesn't happen. None of that stuff happens, okay? So what ends up happening in this situation is that if you add an ampersand here and you add an ampersand here, basically this memory location that you created over here now becomes the memory location that this function references. So this function, instead of creating new memory locations, it just says, okay, I'm just going to look at these memory locations. Num1 is set to this num, and then num2 is set to this one, right? So basically now what ends up happening is that, let me get a new pen. What ends up happening is that if now you change the num to 3000, now basically this particular memory address gets changed to 3000. And guess what? What else is looking at 3000? Exactly this main function over here, right? Whatever is in this main function, this num1 is still pointing to that same memory location. So basically what ends up happening is that if you now change num to 3000 and you want to see out that num1, what you end up getting is 3000. Why? Because it's pointing directly to that memory location. It's the same with num2 and any other variable. If this variable is changed in here because of these ampersands, this value will also change, and if you print out num2, you will get whatever value it is that has been changed, okay? So that's basically how reference parameters work. So this function has been called add by ref, and therefore because we changed num1 to 3000, this variable will be changed to 3000. And I'll just make another example. If I were to change num2 to -1, I'll say num2 is equals to -1, and I call that, and I want to see out my num2, and I run this, then we'll see that my num2 is now equals to -1. So since it works in this example, if I were to only call this add function, that was not going to happen. Now guys, that's basically the end of this tutorial. If you don't really quite understand exactly what's going on, you don't need to worry. You don't need to understand these operations outright at the very beginning. They might become more crystal clear as the more we go into the course, and particularly when we reach pointers. Pointers are also kind of weird in a sense, but I think when we get to that point, excuse the pun, then things will start making a little bit more sense than they do right now. Okay, so I'll see you guys in the next video. Goodbye.